Okay, so let's start with some basic math for nurses, and we're going to start with drip sets, because drip or drop sets, because I think that sometimes those are the hardest. And so we're going to talk about some basics first, and then we're going to move into a little bit of math. So first of all, when you're talking about sets, a standard set, which is what you'd use for an adult for a regular IV, is 20 drops per milliliter. And on these sets, you have to remember that they are all measuring volume. So they're always going to be drops per milliliter. The micro drip or pediatric set are 60 drops per milliliter, and that's because you want to have smaller drops. You're usually given smaller amounts to pediatric, or if you're given a smaller amount to an adult, you would use a micro set, and so they are going to be 60 drops per milliliter. And then blood is usually 10 to 15 drops per milliliter. It depends on what reference you use or where you work. Now remember, while all of the sets are given in drops per milliliter because they measure volume, when you're doing a calculation that's asking for how fast you're going to give it or a rate, it's going to be in drops per minute. So you have to make sure that you don't give your answer in drops per milliliter because that's the volume. You need to give it in drops per minute. And it's always going to be drops per minute because you're not going to stand there for an hour and count the drops. So if you come out with drops per hour, you need to convert it to drops per minute. So I'm going to start with 7 problems that are all including drop sets. Anything from, it looks like there's 10 drops per ml, 20 drops per ml, but it really doesn't matter as long as you understand how to set them up. So here's the 7 problems we're going to do, and I'll go through them one by one. Okay, so here's the first problem. The problem is an IV of 2,000 milliliters is set to infuse over 12 hours using a 10 drops per milliliter set. So this would be a blood infusion set. So since I already told you that whatever you get, you're going to want it to end up in drops per minute, that's the first thing you put on your equation. So it's going to be drops per minute. And so I'm going to put that at the end of the equation because that's what you're going to end up with. Okay, so you're going to have 2,000 milliliters, and so that's the volume, and you're going to give it over 12 hours. Okay, so obviously to get down to minutes, you're going to have how many hours broken down into how many minutes. So the best way to do this would be to get your minutes on the bottom. So that's pretty easy. The next thing that you're going to do is you're going to say 1 hour equals 60 minutes. And that works out perfect because the minute's on the bottom where you want it to be when you get done with your answer. And then you're going to do your 10 drops per milliliter. And this is going to work out great too because you want the drops on the top and the milliliters on the bottom so they cancel out with your 2,000 milliliters that you're going to infuse. So you put the 10 drops per milliliter. Okay, so now it's just crossing and a little bit of math. So the first thing you're going to do is cross out your milliliters, okay, cross out your hour, and then you're left with drops per minute. Okay, now when I was in school we learned to get rid of the extra zeros. If you don't do that, then go ahead and times everything out. If you do that like I do, then you'd get rid of that 0 and that 0 and then go with your math from there. Okay, so once you've crossed out the zeros, what you have left is essentially 2,000 over 12 times 6, which is 72. And that equals, when you times that out, 27.777. So if you're looking at this, and you're trying to get drops per minute, you're going to round up from 27.7 because the number after the decimal or the 10th place is greater, is 5 or more, then you're going to round up because you can't count a partial drop. So the answer is 28. And the answer to your math problem will be 28 drops per minute. And hopefully that wasn't too hard, and we'll start on the next one. Okay, so here's the second problem. 3,500 milliliters are ordered to infuse in 24 hours using a set calibrated at 20 drops per minute. So this one's fairly easy. All you're going to do really is use the same formula that we did before. So you're obviously going to end up at drops per minute. That's what your answer is going to be in. And then start with the volume that you need to get in, 3,500 milliliters, and you want to get it in over 24 hours. And your drop set is 20 drops per milliliter, so we'll put that over here, 20 drops per milliliter. And 24 hours, you've got to get it into minutes, so again you're going to put 1 hour over 60 minutes. Again, leaving the minutes on the bottom and the drops on the top. So from here you're just going to start canceling. Hours are gone, milliliters are gone. Again, left with minutes and drops, or drops per minute. So then again I cross out the zeros, one on the top, one on the bottom. That gives you, so that gives you on top 3,500 times 2 is 7,000. And then on the bottom, 24 times 6 is 144. No, I'm not doing this in my head. I already used a calculator to figure it out. And then when you divide that, 144 into 7,000, you get 48.611. Again, you're going to round because you can't do a partial drop. And since the 10th number is 5 or greater, we're going to round up to 49 drops per minute. Okay, so that's 2 down. And if you're doing okay with this, you can skip ahead where we do some of the infusion sets and I add in some tricky stuff, but for now we're going to do a couple more of these problems. Okay, so this was problem number 3, and same setup exactly. You're going to want to end up with drops per minute as your answer. You're going to start out with 500 milliliters because that's the volume you have to infuse. You're going to put it in over 3 hours, and you're using 15 drops per milliliter. And of course you're going to have to convert those hours into minutes, so 1 hour equals 60 minutes. And then actually I'm going to cancel just a little bit more here. We're going to get rid of this milliliters, that hour, that hour. We're going to change some of these just a little bit. 15 goes into 60, so I'm going to make this a 1 just for ease, and 15 goes in 4 times. So if you simplify it down a little bit, you have 500 over 3 times 4, which is 12. So dividing 12 into 500 gives you 41.666. And again, this is 5 or greater, so you're going to round up to 42 drops per minute. Okay, let's move on to the next one. Okay, just like the others, you're going to put drops per minute, and I'm sure by now you're kind of getting the hang of this. I think we're going to end up only doing 4 of those 7 problems because I think this is, looks like you guys are probably catching on pretty fast. This is pretty straightforward. We're going to put the volume, which is 1,500 milliliters, to infuse over 5 hours. It's a 15 drops per milliliter set. And then of course we're going to change the hours to minutes. So we'll put that in there. Cancel out the units that we don't need. Hours, hours, mills, mills. And then again, I simplify. So what we have left is drops per minute, which is what we want. I'm going to simplify. 15 goes into 60 4 times. And then what you'll have left is 1,500 going across here. You have 1,500 over 20. Then you're going to simplify that and divide 20 into 1,500, which gives you 75. And there's your answer, 75 drops per minute. So you're going to be standing there for a few minutes counting those, but I think you have the hang of it. So let's move on to a different type of problem. Okay, so let's start with some that seem to confuse people every semester. Let's do a little bit of units in volume and do some flow rates. So as you look at this problem, there's 10,000 units of heparin in 500 mils of D5W. So the D5W is not pertinent, so we'll just cross that out. But what we do need is the information that we're going to use a flow rate, and that means it's going to be milliliters per hour because it's on a volumetric pump. So what we're first going to do is put milliliters per hour, because that's what we need to end up when we're done. So we've got 10,000 units, but that's not really what's the most important thing. Is we need to find out how many units are in each mil. So we're going to put the 10,000 over 500, and then it's going to infuse, and this is units. I should always have to put those, and this is milliliters, and then it's going to infuse at 1,000 units per hour. So we're going to put the 1,000 here so that we can get rid of the unit, and then we're going to put hour up on the top. And so then we've got 10,000 units in 500 milliliters, that's here, and then we've got 1,000 units per hour, and that's here. So when we get rid of the things that we don't need, we can see that this is upside down, and so we're just going to have to change the whole thing upside down. So we've got 500 milliliters over 10,000 units, because we need the milliliters to be on top. And then we have 1,000 units per hour, because we need the hour to be on bottom. So the first thing we do is get rid of those units. That leaves us milliliters per hour. And then get rid of some of the zeros. 1, 2, 3, 1, 2, 3. And that gives us 500 times 1, so 500 on the top, and then we have 10 on the bottom. You divide 10 into 500, and you have 50 milliliters per hour, and that's your answer. So the flow rate would be 50 milliliters per hour. Okay? Simple enough. Let's move on to the next one. Okay, here we have a problem that says you have a solution of 500 milliliters of D5NS with 30,000 units of heparin, and it's going at 25 milliliters per hour. So how much is the patient, how many units of heparin is the patient receiving per hour? So what we're going to do is it's going to be units, because that's the units that we're working in, and it's going to be per hour. So when we get done, that's what our answer is going to be in. So the first thing you do is you take the 30,000 units, and this time the units is going to be on top, so we'll go ahead and put it on top this time. And then it is in 500 milliliters of D5NS, and it's going at 25 milliliters. We want this on top an hour, and that way we can cancel out our milliliters and we end up with units per hour. And you can do some canceling with this one as well, because 25 will go into 500 20 times. So this becomes a 1, and this becomes a 20. So then you have 30,000, because it's 30,000 times 1, over 20, and then you divide that, is 1,500. And so you are infusing 1,500 units per hour. Okay, so that's the dosage per hour that you were that they were asking for. So let's move on to the next one. On this one, you have an IV of 1,000 milliliters of D5 quarter NS with 40,000 units of heparin, and you need to infuse it at 1,200 units per hour, so you need to figure out what the flow rate is. So if you're doing the flow rate, remember it's going to be on a pump, and so it'll be milliliters per hour. Okay, so that's what you need to come back with when you get done. So what we've got here, and we want the milliliters on top, so we're going to I'm going to be a little bit more careful this time, make sure the milliliters are actually on top. And so it's 1,000 milliliters, and in that 1,000 milliliters is 40,000 units of heparin. And now we need to cancel out, so this time we'll put the units on top, 1,200 units per hour. So that way we can cancel out our units. We have milliliters per hour, just like we want it to be in the answer. And then again, getting rid of some zeros here, I'm just going to do these because these are even. 1, 2, 3, 1, 2, 3. Get rid of one over there, get rid of that one over there. That leaves us 4 on the bottom because that's the only number left. And then if you go on the top, it's 1 times 120. Okay, so 4 into 120 equals 30. And so your answer is going to be 30 milliliters per hour. Okay, this one is a little bit more like the second one we did, and you need the dosage. It gives you the rate, but you need the dosage. So a liter, let's start with what you're going to need when you get done. You're going to have units per hour, right? And so what you've got is 1 liter of fluid, and let's go ahead and put the units on top, so because that's where we need to be when we get done. So 40,000 units of heparin in 1,000 milliliters of D5W, and it's infusing at 25, and let me just go ahead and erase that. I'll erase the whole thing so I can start over. So we're going to have, we want the hour on the bottom, so we're going to put per hour, and we're going to put 25, that's a 5, milliliters per hour. Again, canceling out the units gives us units per hour, and we've got 25. That goes into 1,040 times, and getting rid of, so the 25 was a 1, and then we're going to get rid of that 0 and that 0. So now we have 4,000 divided by 4 equals 1,000 units per hour. Okay, so that's pretty easy, and that's actually a pretty standard dose for heparin. Alright, so this next one again is flow rate, so that's going to be on a pump, and so it's going to be milliliters per hour. And again, because it says volumetric pump, that tells you what it will be. And so what we need is the milliliters on top, and so we're working with 1 liter, so we're going to put 1,000 milliliters, because we know there's 1,000 milliliters in a liter. And it's D5 half NS, but that's not important. What is important is the units, and there's 45,000 units of heparin in that liter, and it's running at 1,875 units per hour. Okay, get rid of the units, and then we're left with milliliters per hour, which is exactly what we're looking for. Get rid of those 3 zeros and those 3 zeros, And then what we've got is 1,875 over 45. And then you would divide that. And you get a number with a decimal. It's 41.666. And so whenever the 10th place is 5 or more, you're going to round up. So this would be 42 milliliters per hour. Generally speaking, you don't use decimals unless you're working with pediatrics. You would just round up to 42 or round down to 41. And so the flow rate on this is 42 milliliters per hour. Okay, so for this recording, since it's already over 20 minutes, I'm going to stop here. So we covered drip sets using 10, 15, 20, and 60 drops per milliliter, which is the volume. And always remember that those are going to end up to be drops per minute, and there's no partial drops. And then we did units of heparin in whatever volume was in there, and then we gave both flow rates and dosages per hour. So you've learned both of those, and remember we have a review coming up. Make sure you go to the review if you need that, and if you need more personal help, there is a tutor here in the FTC or at the college in the FTC on Wednesdays from 10 to 4 or 10 to 6. I can't remember for sure. But anyway, call over there and you can get a math tutor, and she is a nursing student, so it's a bonus. At least for fall semester of 14, she'll be there. So have a good evening or day wherever you're listening to this, and I will see you at the review.
Made with Doodlecast Pro.